Hey guys, welcome to the fourth episode of the AI series. In today's video, we are going to build our first ever machine learning model. So let's get straight into it. In the last two videos, we talked about what machine learning is and the difference between predicting a number and predicting a category. Today we stop talking and we build an actual machine learning model. By then, you'll have trained a model that predicts house prices in about 10 lines of Python. And this time, I'm going to explain every single line so you understand exactly what each one does and not just that it works. So open up Google Colab and follow along. In our first cell, we are going to do the imports. The first line is import NumPy as NP. This brings in NumPy, the library that handles numbers and arrays in Python. Almost every data tool is built on top of it. The as NP part gives it a short nickname. So later, we type NP instead of the full word NumPy. That's a universal convention you will see in every tutorial. The next line is import Pandas as PD. Pandas is a library for working with data in tables, rows and columns like a spreadsheet but in code. Again, as PD nicknames it, so we can write PD for short. The next line is import matplotlib.pyplot as PLT. Matplotlib is the charting library. The .pyplot part is a specific piece of it that draws graphs, and we nickname that as PLT. From sklearn.linear model import linear regression. Scikit-learn, written sklearn in code, is the machine learning library, and it's absolutely huge. So instead of importing all of it, we use from import to reach into just its linear model section and pull out the one tool we need today, linear regression. And that is the exact model we are going to train. Now, in the second cell, we are going to type in our dataset. So data, and over here we're making a Python dictionary. That's why it starts with the curly braces. A dictionary stores information as pairs, a label, and the data that goes along with it. Size M2, colon, 50, 70, 80, so on. This is our first pair. The label is the text, size M2, and the data is a list. That's the square brackets of 8 house sizes in square meters. Each number is one house. Price K, 150, 200, 230 is the second pair, holds the matching prices in thousands, and the order lines up. The first size, 50, goes with the first price, 150,000. So this house sold for 150,000. The next line is df is equal to pd.dataframe bracket data. Now we hand that dictionary to Pandas with pd.dataframe that converts it into a proper table, a data frame, and we save it in a variable named df, which is short for data frame. The labels become column headers. The lists become the columns underneath. The last line is df. Finally, just typing the variable name on its own line tells Colab to display it. Run the cell, and there's our table. 8 rows, 2 columns. And notice the pattern your eye spots instantly. Bigger houses cost more. Getting the machine to learn that is the whole job. In the next cell, we pull the size column out as our input and store it in capital X. Look at the double square brackets. The outer brackets mean select from table. The inner brackets make a list of the columns we want. Giving it a list keeps the result as a two-dimensional table, which is the exact shape Scikit-learn wants for features. If we use single brackets here, we would get a flat one-dimensional list and the model would complain later. And in the next line, y is equal to df price k, we pull the price column as our answer, which is lowercase y. Here, single brackets are fine because the thing we were predicting is allowed to be a simple one-dimensional list. So, capital X is what we feed in, lowercase y is what we want out. You will see this X and Y split in every single project from here on. If we run it, as you can see, it does not give any output because we not give any output function. The next one is cell 4. Model is equal to linear regression. model.fit x comma y. The first line is when we create a brand new untrained model by calling linear regression with empty parentheses and store it in a variable called as model. Right now, it's blank and it knows nothing about houses. Model.fit x comma y. And this is the entire act of learning. In one line, .fit is scikit-learn's universal command, meaning train yourself on this data. We hand it our inputs x and our answers y, and it studies them to find the best straight line through the points. When you run it, Colab prints a little summary of the model. That's just it, confirming it's now trained. That one word fit is where the magic happens. Now, in the next cell, the first line is we invent a brand new house the model has never seen, 110 square meters, and build it as a tiny one-row table. We use the same column here, so it matches exactly what the model trained on. Matching that name keeps scikit-learn happy and avoids a warning. In the next line, we set the predicted price. .predict is the universal command for making a prediction. We pass in our new house and it returns the model's estimated price, which we save in predicted price. Then we're going to print something out. We're going to print the result, and there are two things to notice. The F right before the opening quote makes this an F string, which lets us drop a variable straight in the text using those curly braces. Inside them, predicted price square bracket 0 grabs the first number from the result. The 0 means the first item, and 1f is a formatting instruction that says show it as a decimal rounded to one place. So instead of a long messy number, we get a clean readout, about 301. And if we run it, as you can see, it gives us 301.1k. The model just priced a house it never ever saw. Now we're going to look at the line. We're going to understand the slope and the intercept. So model.coef 0. After training, the model stores what it learns in special attributes that end with underscore. Coef holds the coefficients for a line, and that is the slope. And the 0 grabs the first one. Since we only have one feature, this number, which is about 2.45, means each extra square meter adds roughly 2,500 to the price. And if we run it, as you can see, 2.45 blah blah blah. The next one is model intercept. Intercept is the other number that defines a line. Where it sits vertically, its starting value. Together, the slope and the intercept are the model. Just two numbers distributing one straight line. Exactly how it landed on these two numbers is the whole story of the next few videos. For now, see that the model is this small. Now we're going to visualize it. In the first line, plt.scatter, scatter draws individual dots. The first argument is the horizontal positions, our sizes. And the second is the vertical positions, our prices. We will color them blue, and label gives them a name for the legend. These dots are our 8 real houses. In the next line, plt.plot, plot instead of dots draws a connected line. The x values are the same sizes, but the y values are model.predictx. The model's predicted price for each size. So this draws the straight line the model learned in green. And the second line is plt.scatter. This gives one more dot in red for our 110 meter prediction. The s is equal to 100 sets its size bigger, so it pops out from the rest, which is the s is equal to 100. plt.x label. These label the horizontal and vertical axis so anyone can read the chart. plt.legend. This tells Matplotlib to actually draw the little key in the corner using the labels we set on each piece. And plt.show shows the finished chart. It's always the last line when you're plotting, and there it is. When we run it, as you can see, the blue dots are our real houses. The green line is the model, and the red dot is our prediction sitting right on it. The green line is everything we just built, and that is linear regression. If this video helped you understand how we code a basic machine learning model, then make sure to subscribe and hit the like button for more videos like this.